So I don't have a ton to say about dividing radicals. I'm going to show you how to rationalize at the end here, but really the big part I want you to know is that this quotient rule for radicals. And what that is that if I have a fraction, so quotient, under a radical, I can split that apart and do, so if I have the square root of a divided by b, I can write that as the square root of a divided by the square root of b. Sometimes it just makes it a little bit easier to simplify. So here's an example, divide and simplify. Square root of 9 over 10, well, to find that, we just do the square root of 9 divided by the square root of, 100. Square root of 9 is 3, and square root of 100 is 10. So just kind of doing it that way. Now, again, this is that whole being flexible. It's like, which way is better this time? So if we look at our next example, I have the square root of 75 a to the 14th divided by 3. I don't know what the square root of 75 is, so having a square root of 75 is not going to be helpful to me. But in this case, if I divide first underneath, then that is nicer because 75 divided by 3 is actually just 25, which is a nice perfect square. So that is helpful. Right? Sometimes it's more helpful to be together. Sometimes it's more helpful to split apart. So you just want to kind of be looking ahead a couple of steps and seeing, okay, which one's better this time? Okay, so square root of 25a to the 14th is 5a to the 7th. Okay, how about this next one? I have the square root of 300, x to the 4th, and then in the denominator, the square root of 3. I don't know the square root of 300. I don't know the square root of 3. However, right, they're both square roots. So it's kind of like using our quotient rule backwards. So I'm going to put these two under the same radical. Make one fraction under the radical. 300x to the 4th is on top, 3 is on the bottom. Now I can simplify inside, right, the radical. So simplify that fraction. 100x to the 4th. Now everybody's a perfect square, right? I know it's a total math teacher problem. I made it so it would work out. But, right, the idea is that you're looking ahead and trying to figure out, right, which way is better for you this time. Okay, so what is that? 10x squared. Okay, finally, I have a cubed root. Ooh, okay, so let's go ahead and split that apart. I don't have any numbers here to simplify. I could do these two here. I could, oh no, one's an A and one's a B. They're not like bases. I can't combine them. They're going to stay apart. So I'm going to go ahead and split one up for the top. Cubed root of 125a to the 12th. On the denominator, cubed root of b cubed. Okay, everybody in the numerator is a perfect cube. So we do the cubed root of 125. That's a 5. Cubed root of a to the 12th, that's a to the 4th. Cubed root of b cubed, that's a b. Okay, so I will show you how to rationalize denominators if there's one term. I'm not going to show you the two terms. There are other videos that you can find for that. We're just going to do rationalizing the denominators if there is one term there, so monomial. So rationalizing in math means rewriting, finding an equivalent expression, rewriting without radicals in the denominator. So we want to find an expression that's equivalent but does not have the radical in the denominator. So since we're only dealing with expressions, the most we can ever do is multiply by 1. Well, okay, we can do operations that are told to us, right, to do. But other than that, right, if we're coming up with, gosh, what should I do to make this nicer? All you can do is multiply by 1, right? Of course, we're just going to be clever about how we write 1. So let's look at 1 over square root 2. So here I've got a square root of 2 in the bottom. I want something equivalent to this numerically, but that does not have a square root in the denominator. So what I do is I need to multiply that bottom by a square root of 2. I'm just going to kind of come across to the end. So square root of 2 times square root of 2 is 2. Look, I have a denominator that doesn't have a radical in it. Now I'm going to come back over here, right? I can't just multiply the denominator by a square root 2. What I need to do is multiply top and bottom by square root 2. Right? So here's our very clever way to write 1. Square root 2 divided by square root 2. Okay, I've already done the denominator part, so we'll just do that numerator. 1 times square root 2, square root 2. So 1 divided by square root 2 is equivalent to square root 2 over 2. These two are the same number. Okay, just different forms to have them in. Okay, so let's practice real quick. 3 over square root 7. So what are we going to multiply top and bottom by so that the denominator doesn't have a radical in it anymore? Square root 7 times square root 7, 7, right? And 3 times square root 7 is just 3 times the square root of 7. We just smush them together. Okay. Same thing top and bottom. Right here's our 1 in hiding. And we have, right, an equivalent expression.